Hey everyone, and welcome to another AlgoSkills LeetCode tutorial video. In this video we're going to be going over LeetCode 2717 semi-ordered permutation. So we're going to be breaking down the question, then we're going to be moving over to the whiteboard where we'll kind of go through some examples and work out how we're going to solve the problem, and then finally we're going to write some code. So before we get into that, let me say if you are serious about data structures and algorithms, you want to land that dream job, you want to kind of ace those software interviews, then I'd highly recommend checking out AlgoSkills, our course. Link will be at the top of the description. You know, I'm an ex-Amazon software engineer. I've done it before. I've gotten into Fang before. I teach you those exact skills required to get there. So if you want to get into, you kind of want to land that dream job, I'd highly recommend checking it out below. But let's get into this question. So we'll give it a read first. You were given a zero-indexed permutation of n integers, nums. Okay. A permutation is called semi-ordered if the first number equals 1 and the last number equals n. Okay, you can perform the below operations as many times as you want until you make nums a semi-ordered permutation. So the operation that we can perform is pick two adjacent elements in nums and then swap them. Okay, so from what we've read so far, we have this list of numbers which is not going to be in the correct order, or likely will not be in the correct order. And then we just need to swap them until we can get 1 in the first position and n in the last position. So that's all it is. It's just a matter of swapping some numbers around so we can meet this criteria here. And then so what we're going to return is the minimum number of operations, so the minimum number of swaps to make nums a semi-ordered permutation. And so a permutation is a sequence of integers from 1 to n. So that's just saying that this permutation of n integers is going to have all the numbers from 1 to n. So we've got some examples here. I'm going to move over to the whiteboard because I think it's going to be a bit clearer if we go through them there. So we'll start with 2, 1, 4, 3. So let's kind of think about this logically, right? The only numbers that we care about are this 1 here, n, because this is 1, 2, 3, 4. This has an n value of 4, this 4 value here. So what we need to do is we need to get this 1 value to the start, and we need to get this 4 value to the end, right? So, and we need to do that by swapping two adjacent integers rather. So we can see that that's not super difficult, right? Like let's just kind of go through it how we would if we were doing this manually. So let's start with the 1, move it to the first position. So this is going to produce 1, 2, 4, and 3. Okay, and the 1 is in the first position, so this is good. This is perfect. We have the 1 in the position we want. Now we just need to focus on this 4 value here. Okay, so we need to get 4 to the end, so let's move it here, and our output after that would be 1, 2, 3, and 4. Okay, so now 1's in the right position and 4's in the right position. So this is the ideal position. This is what we are trying to get to. This is the desired result, right? And we did it. So that's all the swapping we need to do. That's the desired outcome. One important point to note here is just to kind of emphasize it further. We only care about 1 and 4. So these numbers can be in any order. This could realistically be, this could be 3 and 2, right? And this would still be fine. Obviously, it doesn't work out like that. But if this was a 3 and this was a 2 and we swapped them around and it ended up being 1, 3, 2, 4, this would still be perfectly fine. We literally just care about this first element and this last element. Okay? And so how many swaps occurred here? We have 1, then we have 2. So we only have 2 total swaps, right? So that's kind of how it's going to work. And of course, if we could write the code to literally just kind of go through and do exactly what we just did then. We can just go through and just swap them around until we get to the right positions. That's not ideal. We can definitely do it in a much quicker way. So if we kind of think about this, we're always moving 1 to the start and we're always moving n to the end, right? So kind of the first intuitive thought is, okay, the amount of swaps is literally just how many positions 1 is away from the start, and in addition to the amount of positions n is away from the end, right? So 1 is currently 1 position away from the start, and n is 1 position away from the end. So 1 plus 1 obviously equals 2, which is what we want. So that seems to work. This seems to be a viable way to kind of reach the desired output. But let's take a look at another example. So now we have 2, 4, 1, 3. Pretty similar. But let's use this approach, right? Let's use what we just worked out here, and let's guess what we think the output is going to be before we actually go through and do all the swaps manually, right? So 4 here is in position 1, and it's 1, 2 positions away from the end. Okay, so that's 2. 1 here is in position 2, and is 1, 2 positions away from the end as well. So we're going to expect it to be 2 plus 2 equals 4. From what we just worked out in our last example, that's what we think it's going to be. But let's actually do it manually. Let's take a look at let's take a look at what it is when we work it out. Okay. So again, all we care about is this 4 and this 1. So this time let's start with the 1 again, just because that's what we did last time. So we need to move 1 to the start. So we're going to swap 1 and 4 here. And then that's going to give us 2, 1, 4, and 3. Okay. And you'll notice that we're now pretty much in the exact same starting point we were before. So let's do those swaps. So we'll move 1 to the start. So it's now going to be 1, 2, 4, and 3. Okay. And then finally, let's move 4 to the end. So that's going to give us 1, 2, 3, and 4. Okay. So we've got the desired outcome. 1 is in the first position, n is in the last position. Let's take a look at how many swaps occurred. So we had 1 swap occur here. We swapped these numbers. Second swap occurred here, and the third swap occurred here. So we actually only had 3 swaps, right? So this didn't produce the expected output. It was 1 more. So why did that occur? If you think about this here, this swap here, when we're adding this up using our original approach, which is that, okay, it's the amount of swaps to the end for 4 and the amount of swaps to the start, or amount of positions to the start for 1. It doesn't consider the fact that this is only 1 swap, but we're treating it as 2 separate swaps. We're treating it as 1 swap, for moving 4 this way, and we're treating it as 1 swap for moving, not like a distinct separate swap for moving 1 this way. When in reality, it only occurs as 1 swap, which is why this was 1 more than our expected result, or like the actual result rather. So this is just kind of a special case that we're gonna have to consider in our code. But essentially, our original approach that we worked out, which is literally just how many positions is 1 from the start, how many positions is n from the end, that works completely fine as long as we account for this special scenario here, right? So I hope that makes sense. Let's get into actually writing the code now. So we'll start with just declaring n, because it's just going to make our code a bit neater. So I'm going to call n equals length of nums, and then I'm going to have a variable called 1 position. I'm going to initialize that to 0. That's just going to hold the position of 1 when we find it, and then I'm going to have n position, which is going to be 0, and that's going to hold the position of n when we find it. So now let's iterate through every element in nums. So for I in range n, then we need to see, is it 1? So if nums of I is equal to 1, then 1 position is equal to I. Otherwise, if nums of I is equal to n, then n position is equal to I. Otherwise, we don't care about it. We're just looking for at 1 and n. And then by this point, we found the position of 1, we found the position of n. we're almost ready to return our result. However, we need to account for that scenario that we described in the example. So I'm just going to create a variable called minus swap. There's probably a better name for it. If you think of a better name, feel free to use it. And this is going to be 0 in scenarios like the first one, where 1 and 4 or 1 and n don't have to be swapped. So 1 is to the left of n and n is to the right of 1. So it's just going to be 0. However, in scenarios where, like this second one, where they're on opposite sides of each other and they need to cross over and they need to be swapped, we're going to equal it to -1, so we can subtract that 1 swap. So if the position of 1 is greater than the position of n, in this case, they're going to have to be swapped. So I'm just going to call set minus swap equal to -1, so we can remove that duplicate swap. And then finally, let's return the result. So I'm going to return 1 position. This is the amount of positions. 1 is from the end. And then now I'm going to do the number of positions. N is from, the 1 position is the amount of positions. 1 is from the start. And then n position, we need to now add the number of positions. N is from the end. So it's going to be n minus n position minus 1. And then finally, let's add our minus swap. So this is going to remove remove 1 if they need to be swapped. So let's submit this. Let's see if this is running fine. As you can see, it passes all the tests. So I hope that was clear. I hope this video was helpful. If it was, it would be much appreciated if you would like and subscribe. Thank you guys so much for watching. Have a good one.